A structural engineer is someone who looks at different building materials and ensures the strength is adequate to serve its purpose. When you look at a building or any structure out there, you can visualize a skeleton behind all the facade and the appearance of that. We designed that skeleton structure so that it can withstand a variety of different loadings, whether it be wind loads, snow loads, equipment loading in the building. Arcadis is a larger consulting firm. In the engineering field, it ranges from small family-owned engineering firms to individuals practicing engineering, all the way up to larger firms. One of the benefits of our large firm is we have a breadth of knowledge and many technical experts in many different fields, so we can pull all of that knowledge together to serve our clients' needs and provide the best solution.
I wanted to pull you in because we have some conflicts with some pipe supports as well as a VRU foundation.
A typical day for me involves working on different design problems, whether it be designing a concrete slab or a steel beam. I typically have a few meetings throughout the day with other disciplines. I also receive various phone calls from construction projects asking questions on how site condition may be changed and we need to accommodate that change. One of the cool tools we have as structural engineers is analysis software. We can actually build 3D models of the structures we are going to build. We can piece together the structure with each beam and column, and then we can apply loading to this structure, whether it be snow load, wind load, equipment loads. We are then able to see a deflected shape of our building. This is exaggerated, of course, but we can change our load cases and see how that affects the building. Constructability review is something else that's very important to us as engineers. A lot of questions we get deal with how is the contractor going to build this, and that's something we want to bring back into the design process to mitigate those concerns. So if, for example, we can ensure there's enough clearance around a bolt that they can get the wrench in there to tighten that bolt, we want to make sure we account for that in design. Whether it be head clearance, if you're going down a stairwell, we want to make sure that there's enough room while they're constructing this to get access to the areas they need to build it. One of the beams we had in question was this beam right here, and we were wondering if we might be able to make it a little shallower and a little wider. If you're interested in engineering and structural engineering specifically, I would encourage you to, as always, go after the math and science classes in high school. And even more so important today than ever is the communication skills. I can be the most technically sound engineer, but if I can't communicate and convey my solutions to others and put it on paper, it's lost. Yeah, so that's the beam we're talking about. Education requirements for a structural engineer involve a 4-year degree at an accredited university. You're required to take math, physics, chemistry courses, materials classes, and once you complete your 4-year engineering degree, you can then practice in industry. If you want to pursue a license, you're required to work under a professional engineer for 4 years. Every state has different licensure requirements, and once you obtain that license, you're then allowed to stamp a design, and the whole stamp process is required to ensure that a competent engineer is reviewing and designing a project so that when it gets built and is occupied by the public, it is a safe structure. What I enjoy most about my job as a structural engineer is the constant challenge and change. Every day I come in, I'm not exactly sure what new project I'm going to be working on, and the opportunities are endless, really. We're constantly expanding into different areas, and there's always a need for a thought-out design and structural engineering perspective.